Good evening, everyone. This is Janik Alford, and tonight I'm going to talk to you about a project of mine that's been slowly evolving over the last couple of years. It's a patent that I've recently been granted by the US Patent and Trademark Office for some data processing inventions that I've been working on. I have a copy of it here, the official copy with the official yellow seal on it. And the patent is called System and Method for Indexing Large Volumes and Durations of Temporally Based Sensor Datasets. The idea behind it started about 5 years ago when I started working on these devices. This is one of my Simeo sensor devices. And this device is a multimodal sensor device. So how it works is it collects audio and light and touch and motion, magnetic field, and then interaction via these capacitive touch buttons on the front. So think of it as a kind of a sensor hub, if you will. And I built a few of them. They come in sort of different sizes and configurations and things like that. The purpose of them was to be able to create a platform for capturing large amounts of sensor data throughout your life. And so the idea is that these would capture all sorts of sensor data, but for an extended period. We're talking months, years, decades, the better part of a lifetime. And in these sets of sensor data, you would find the patterns of life. So you have voice prints, and you have motion, and you have interaction, you'd have movement, you'd have touch, you'd have all these different kinds of features hidden within the data sets. How can I think to utilize so much data? If you have decades of data and you've got dozens of sensors, you have hundreds of years of data. And so how do you find the needle in the proverbial haystack? So I'm going to walk you through some of the ideas in the patent and how it responds to that challenge around big data. So here we're going to search for the patent number. Here it is, 11983156. So search for that. And it should come up here. So there's the patents, and I'll actually take it right to the PDF. So I'm going to walk you through this here, and I'm going to highlight some key parts of it, right? So data sets intended for human experience usually capture sound and light and movement. There's so if you have a broad spectrum sensors, you could be detecting outside of the human realm. But such systems, many such systems implement encoding and storage methods, and storage has grown. There's something called Kreider's law, which maps how storage capacity grows over time. But once you have video and audio, again, for days, months, years, or even decades, then there's really no upper limit to the amount of data you can be generating here. So long-form data sets they contain these comprehensive narratives and histories of individuals and events. So think about, if you were to turn on a sensor like this that has audio and motion, touch, interaction, etc., environmental sensors, and you were to run it for 40 years, you would expect that in that time frame, you would collect the features of your life. So everywhere from the strictly biographical, like what do you sound like, what does your voice sound like, how does your voice change over time, to the conversations you have and things like that. But once you start to capture that much information, you really run into a problem. And that problem is longer data sets do not inherently mean that the data is more meaningful, only that there's a greater likelihood of valuable information that may be contained therein. So the ratio of low quality data and high quality data becomes less optimal the more you capture. And finding that valuable data in decades of information is pretty much impossible through other methods, is the case that I've been successfully able to make. There's challenges in recognizing where's the valuable data. There's also challenges just strictly viewing it or seeing it or listening to it. And so I talk a little bit about how existing methods do not allow for us to provide gain a deep insight into what a file might contain. So if you had a video file that was a year long, for example, typically when you see a video file, it's kind of broken up into these thumbnails or whatever. But that thumbnail, like you have one thumbnail per month. What happened in that video? is really, really hard to figure out unless you use some of these methods. And so, so hence an improved system for identifying and indexing occurrences and regions of heightened subjective value to optimize search, summarization, isolation, abstraction, and analysis of long-form datasets. The method taught by the present invention will be a significant enhancement over any other method of indexing and identifying the subjective value of sensor data that is available. So all this comes down to is essentially being able to pool large amounts of data and then extracting narrative from that. And so I have a whole bunch of pictures that sort of show how that works. I'm going to show you some of those pictures up above, but it really comes down towards, here, let me see if I can rotate this. Yeah, I can rotate that. One more time around, I'll zoom out here. It really gets down to, if you can make your heads or tails of these grainy images, down to recognizing patterns. So you can read a little bit what this is, gross feature analysis. So there you're hunting for kind of the features and the boundary conditions between different features, silence and audio. Then you break it down into different metadata which you're able to map out. And then you're able to implement fine feature analysis. So essentially, once you find human human speech, then you can go back and actually determine what it is. So you can start to do that with visual as well. So there's a face that has feature classification. You have audio that has feature classification in it as well. You start to be able to extract out metadata understanding. And then you actually start to be able to turn metadata, and this predated the large language models, but these would be phenomenal at doing this, but you can parse out narrative metadata or narrative descriptions from metadata. So if you had information of someone sleeping, walking, standing, exercising, being at home, being at work, or talking, those are all different pieces of metadata or categories of metadata that you might deduce from a large amount of sensor data. Then you could actually infer a narrative from that text using textual narrative generation. And then this is the key part for the patent that is really interesting. So the idea is when you characterize occurrences, you actually see them over a time. So here you have 3 months of audio where you're mapping out the amplitude of incidents. So the number, roughly the number of times these things are occurring per day. So you can see there's some seasonal change, bird song is going down, utility noise is going up, construction noise is going up, so you sort of have a change of seasons maybe. And you've got multiple different patterns of metadata, and when those diverge all at once, you found yourself an index of subjective human value. So what happened at that point that would cause all of those things to diverge? Now that might mean you went somewhere. It might mean that you were sick in a hospital. It might mean that you took a trip or you're in a different location. Those are all things that would cause pattern recognition to diverge across multiple different channels, and that forms an important life index. Those can be temporary or permanent. And this is the other key part of the patent, is the idea around using predictive models to look for divergence against the prediction. So for example, if every day you get up and you go to work, and then one Thursday you simply don't do that, and instead across multiple sets of data, all of the things that you're predicted to have done that day failed, then you might infer that there's something subjectively interesting about that time, enough to put an index there and enough to draw a person's attention to it. So it's the use of pattern recognition with this idea of consensus divergence on on predictions to form the most insightful indexes on your lifetime. And so if you map it out of over 40 years here, we have someone's theoretical life. You can see that there's an important life event happening here at 25, and that's driven by the inferences around the pattern recognition and the prediction. So there's concurrent divergence across multiple different factors that would suggest that that person was off doing something different from what they normally did. So the diagrams break it down in principle. There's some of the visualization pieces of it, so you can visualize this over a sliding time scale, and you can start to export it out. So this gives you the sense that instead of current methods of using image and text visualization or video visualization or kind of scrubbing across the timeline, you actually can deploy this mass indexing of data and then find and search and identify these interesting facets within your data. So that's essentially what the patent's about. I'm pretty proud of this one. It threaded the needle, I think, with the patent office and with a lot of help from my lawyer to navigate this. And I do appreciate them taking the time to understand the nuance of it and why it's unique. It's not often that you can get a utility patent on software. But in this case, I do have something that I can now start to make available and incorporate into new inventions and technologies. And if you look where things have come in the last 5 years, 4 years, you now see things like AI pins and wearables and other things like that. You've got your smart devices, your Whoops and your different Aura rings and your other things that are collecting information. As you start to integrate all those things together, this patent provides the best method that I've thought of, and hopefully it's valuable to others, to capture and weave together a life narrative and really come up with the most comprehensive biography you can imagine from this data. So as we go into the future and as we start to utilize AI more and more, this provides a means of even explaining your life story to AI in a way that's much more insightful. So you could even utilize the metadata here, feed it into a large language model, and then it would gain a deep understanding of biographically who you are and what you've been up to. I captured a lot of these concepts in the book, Intelligent Digital Ecosystems. So what I'm essentially describing is the concept, I forget which chapter it's in, chapter 4 or something like that, of a reservoir of data where you can use these technologies. There's the Simeo device I was talking about, where you can use these technologies and build yourself essentially an intelligent digital mind, a partner in the digital space to extend your mind and things like that. I was a bit strategic in developing the patent. I was attempting to put this out to market, but because of the pandemic, all of the components were really hard to get. There's a supply chain collapse for a better part of 18 months, actually, that prevented me from moving it forward. And I also knew that I wanted to do the book, which has a lot of those ideas that I talked about in it. But I knew if I put the book out first, I would actually block myself from getting a patent because I would be putting out prior art myself. So I paused the physical device, I paused the book writing, and that's where I put the patent out. And I think it worked out. So you can check this out. Most patents are in the public domain. So you can go and have a look at that. And if you have any questions about the patent or the patent process or how I might be using it next and you're interested in that, I'm always happy to talk shop or explore ideas. So hit me up and follow along. I'm going to do more of these videos in the near future. And I'll be talking about how we can start to leverage some of the data that we're capturing here and build really innovative agent-driven architectures that extend our ability into the digital realm. So if that sounds something that you're interested in, follow along and I'll be happy to share those things as we go forward. Thanks a lot.